Y'all are in for a real treat today. I'm gonna sing the blues on my brand new pink ukulele, much to the chagrin of my wife, who's sitting right here, and she hates being the center of attention. Check, check, check. Can I get more of me in the monitor? There's no monitor? Okay. Let's give everyone a hand here for helping out, for the staff. Check, check, check. Checked my branch, popped the stash. Still don't know where it is at. Tell me, have you seen my code? How'd I get this detached head? Don't blame me, I'm innocent. Oh, tell me, have you seen my code? So if you run into a beautiful commit, code complete with the testing suite, bet your life that isn't it. That's okay, 'cause it's a whip, and now it's never gonna ship. Oh, tell me, have you seen? Tell me, have you seen? Oh, tell me, have you seen my code? Please clap. Welcome to the jungle. Git is a terrifying jungle, and it is easy to get lost. This song was inspired from Jim Wyrick, who was a wonderful man. He wrote a version when we kind of had a day off from work, and he called it, "Have You Seen My Code?" He was singing about how much he loved Ruby code. If you've ever heard it before, he ends up singing about how much he doesn't like Java, and he actually came to me the day that he wrote it, and he's like, I need some really frustrating things in Java. So the mentions of like entities and EJBs and stuff, that I was responsible for those lyrics. I'm very proud of that. So that was actually originally based on a song that was really popular in the 20s. Has anybody seen My Gal? So this parody for Git, I wrote it for Jim. It was a tribute to him. He's a great man. Coincidentally, though, it turns out someone else that works at the same company as me at Test Double, I just found out in the last 24 hours that he also did a parody about like bad code. Have you seen this code? And so maybe you could consider my song actually a merge commit. Oh, I'm full of bad puns. We're just getting started, son. All right, this is who I am. Marc Peabody. I'm a double agent 0027 at Test Double. And I do Ruby, I do JavaScript. I have some Java in my background, but you know, I love Ruby a little bit more. I love JavaScript a little bit more. And I like running, punning, and gaming. This is my family here. We're one shy of a Brady Bunch. So if anyone has like a son that they're willing to get rid of, maybe we'll take him on if he's good at mowing the lawn. If you have a maid, we could use an Alice. Just putting that out there. I work for Test Double. We're a consulting company, not a product company. Everyone thinks, okay, Test Double JS is what we all sit around and write all day, but it's not. I don't actually even use it at most of my clients. But yeah, we love what we do. We love helping people get better at the things that they're doing with their code. So please get in touch with us. We're hiring like crazy the last year, and we're hoping to keep that going. I want to introduce you to a couple friends. You'll see their faces pop up from time to time. We have Mona. She's a monkey. She's going to be one of our guides helping us along our path today. And Lisa, who's a hippo. And they both actually happen to be developers themselves. They're quite good at it. Okay, so one bit of warning to everyone. This is an intermediate Git talk. But show of hands, and I can't see the other theaters, but that's fine. Who has never used Git before? We've got a couple. All right, so I hope there's going to be a few things in here that you can take out of this and still, like, when you first get into Git, like all the frustrations that most people have to deal with, you might be able to sidestep some of those. How many people use Git a lot, but you kind of do it nervously, like, oh my goodness, I hope something bad doesn't happen? I know, right? That's like everyone. And I've been using Git for like almost a decade now, and that's how I felt most of my career using Git. I was like, oh man, I hope this doesn't get me fired. I hope someone didn't force push again. Git is hard. It's like being in a jungle full of trees, and at any instant you could end up feeling totally lost. Let's talk about how mistakes can get made. Yeah, Mona, sometimes it is your fault. And it's probably just because you're not giving yourself enough feedback. Git is a very Unixy thing when you're on the command line especially. If you're on some visual tool, it might help you out a little bit. But if you're on the command line especially, you need to be giving yourself feedback. And Git's only going to give to you the feedback that you ask of it. So you need to make a point to constantly be asking for it. And yeah, a lot of the problems are actually Git itself. Git is wonderful. You're here not just because Git is hard. If it was just hard, you wouldn't be here. It's because you love Git. You know that Git's cool, and it's probably good for your resume. What are some of the things? Leaky abstractions. So Git has this separation. It seems like almost every framework has some level of abstraction. There's a lot of complex things going on all the time, but they want to make it so that you don't have to think about all those complexities. They don't want to show you how the sausage is made. Just give you a few basic commands. Just stick to these, and you'll be safe. Well, the problem with the abstractions is they leak. And with Git, I guess ironic isn't the right word. It's a big coincidence that they've separated their two types of commands into being named porcelain and plumbing. Okay, it's like a guaranteed leak waiting to happen right there. So you're supposed to be using these porcelain commands, and oh, this looks a lot like using subversion. Okay, I can understand this. But then something doesn't quite go the way that you thought it would. So then you have to understand the underpinnings of everything that's going on in the plumbing just to be able to find your way back out. We hope to resolve some of that today. Another problem is inconsistent API. There's really not a lot I can do to fix this in the next hour, but there's a lot of commands that maybe a dash something means something for this command over here, but we need the same kind of thing on this other command, and it's dash something else, or it's just the default parameter on the other command. And sometimes there's overloaded commands. The worst ones I feel are like checkout and reset. Like it used to just be like way a long time ago that the only thing that you could supply these commands is like, you could say master or head or something like that. You couldn't supply a file path to it. But then they said, hey, you know what would be really useful? Is if we also had this ability. I know, let's just throw it onto the same thing, and it'll be so useful. And so now you've got checkout. When you check out a branch name by itself, it does one thing, but if you say checkout and give it a file path, it does something almost seemingly completely different, and that can be really confusing. Finally, it could be someone else's fault that mistakes were made. Lisa, why'd you force push again? Okay, so first of all, if you ever feel like you have the need to force push, first of all, do force with lease. So that'll help make sure that you really don't stomp on any more stuff than you meant to. But don't force push if you can help it, please. Unless it's just your own branch. But probably don't do it either. Just don't. Unless you really need to, but don't. All right, so giving yourself some feedback. Git status. All the time. There's so many times you make mistakes of where you're just like, oh, dude, I didn't even realize. I forgot to add that file. Git log all the time. It's really helpful. It's maybe less helpful if you don't give the dash one line, dash graph, dash all. And all that stuff's extra confusing. You can make an alias for that. We'll have that. Git fetch all the time. All the time. See all the branches get pulled down that are out there. Make sure that your master is up to date all the time. And git diff, well, whenever you need to. So, years and years ago, Git was just this confusing thing. We didn't have a whole lot of documentation. The documentation we had wasn't that great. There weren't many talks on it yet. And then suddenly there was this pretty good talk about Tale of the Three Trees. The three trees are head, index, and working directory. When I first saw this talk, I was like, great. This is another abstraction. Now I have to think about all these trees. This isn't helping me. Pictures of trees? This looks nothing like Git. Well, actually, the working directory portion is pretty straightforward. It's just your file system. And head is really just a pointer that follows you everywhere you go. And it points at whatever commit is that you're working against. And index, well, it represents something kind of in between the two states. We'll look into that in a couple minutes and see how all of these things work. With Subversion and maybe some other systems, you only had to keep track of, well, there's my machine and there's the server. And I just, boom, dump all my stuff out or pull all my stuff out. And it's pretty simple. There's not that many things to keep track of. This is one of the things that makes Git harder to work with. There are more things to keep track of, but with great power comes great frustration. But it makes you more powerful. So we talked about one of the trees is head, which I said is just a pointer that follows you around. And it points at whatever commit you want to be working against. But what exactly is a commit? Well, we could say it's a snapshot of everything that you want to be in your project at a certain point in time. Well, that's a pretty good definition, but what does that actually look like? Let's make some sausage. So our first demo, we're just going to start out by building out a working tree. It'll have nothing to do with Git at this point. Let's just build this out. Shouldn't take too much effort. So I actually will have these demos divided up into 3 separate panels, and let's make these bigger. I don't know why they're so small. So the top left is where we're going to be working out of for pretty much the whole time. Over here, I'm mostly going to be having a Git status up here, and down here it'll be lots of different things that'll be similar to like either a find or a Git log or something like that. This is around giving the types of feedback to yourself about the state that Git is in at any given point in time. I started actually working like this when I started preparing for the talk, and I actually love it. I'm actually doing this all the time now. I don't use a visual tool when I use Git. I use command line for almost everything, and I'm really loving the way that this is working out. So actually in the bottom panel, I'm going to start using a command called watch. Now watch is essentially just something that's going to keep executing some command over and over again and refreshing the screen with that. And I want it to do it every second. And all I want to do is find. So right now we have a directory that's completely empty for our project. Let's start adding some stuff to it. So what did that need to look like? So git talk is our root level directory that already exists. We need to have a welcome file. Let's build that out. So echo, hello. I need to escape my bang here. And we need to call that welcome.txt. Oh, wonderful. It showed up down here. All right, so we need to make a directory called guides. And to it, we need to add our 2 guides. Our names are Mona, and that needs to go inside of guides and under monkeys, I believe. Let's double check. Monkeys.txt. And then let's do another one for Lisa. And also will be under guides, hippos. Okay, so we have our working directory already in place. It's one of our 3 trees that we need to worry about and keep track of. Okay, this is all pretty simple stuff. All right, let's actually jump out to here and create a Git project. All right, boom. Suddenly, this panel got a lot more interesting. So we have this .git folder that got created. Now, everything that exists in the realm of Git is pretty much going into this directory. It doesn't do like .git files in other subdirectories like you might see in Subversion and some other places. It's pretty much all going into here. So now that we have a Git project, let's do a Git status. Oh, this is nice. Okay, so not only does it tell us what the difference is between the working tree and the index, and also the difference between the index and the head, which head doesn't really exist, and well, actually the index doesn't really exist yet either, but we'll get there. I actually git status -s. It's shorter and I can see things better. It doesn't give me helpful commands to figure out how to like reset a file to pull it out of index or anything like that, but I like it better. I also like to see my name of my branch, so I like to put a B in there as well. That's great. So I actually have a command that I have aliased out as a function. It's called xstat. And it's also a watch command, and it has some stuff in color just to make sure that the colors get passed along so that you get to see pretty colors. So let's run xstat. Okay, so this is going to stay up to date for us all the time. This is wonderful. We're not just throwing commands into this nebulous void that is git. And then down here, let's actually I have a command called xtree, which is going to be watching our .git directory. So looking at the things in here, right now it's almost just nothing but directories, not much of any content. The only thing that's out there at this point, let's look at it, the head file. So right now, the content of it is this refs, heads, master. Well, I know there's a branch called master in almost every project. Maybe that's the thing that it's talking about. But if I look at that path down here, refs, heads, well, master doesn't exist yet. When you first start a project, master kind of exists. It's considered an unborn branch. And then it's going to exist sometime in the near future, and we'll take a look at that. So, let's add welcome. So here we're taking our first file, adding it into the index. If anyone's been using Git before, this is no surprise to you. It puts it into our index on our git status. It shows it to us. But down here in our objects directory, something new got created. And it actually the name got split up. So the big long thing that we see here, the 4EFFA1, the rest of this stuff, is actually the SHA of the file that we just added, the welcome.txt. So let's actually look to see what that looks like. Get objects 4E. Uh-oh. Wasn't expecting that. I think my computer broke. Okay, well, actually what happened here is it's just compressed. It's zlib compression, and then we can actually take a peek into what that looks like. I have a command locally to do that. So what actually goes into the file that's compressed is the word blob. All blob means is it is the git object type of anything that was a file on our working directory. Not a directory, not a commit, but an actual file. The next thing is the number of characters that existed, 7, and then the contents of our file. Observant people will notice that there's only 6 characters here, not 7. Well, maybe it's ODC. The actual file itself, welcome. You'll see there's actually a /n at the end, and that's what the 7th character is in that case. So it's not great to have to say, okay, I want to uncompress these files to see what they actually look like. In our Git objects, that's a lot of work. It's a lot of pain. So let's introduce you to your first plumbing command of the day, cat file. So what cat file can do is look at any of those 3 parts of what gets compressed inside of that file in the Git object. And then we can pass into it the SHA. We only really need the first 4 characters most of the time. Stuff you read might say that you need at least 6, and in bigger projects where you have more than just a couple files, you might, to avoid ambiguity. So another thing is the SHA, if the contents were ever to change in the file, the SHA would change, which would mean you'd have a completely separate file in the Git objects when you've added something that has different contents. Another thing that you might notice is that the actual file name wasn't involved at all in this Git object. That's actually stored off into the tree, kind of as a pointer to the object that we're keeping track of here. Some people that are like real security nerds might be like, well, how do you know that some hacker couldn't come in and change your contents and just figure out how to do it in a way that uses the same SHA? Well, I did some of the math on that. I ended up figuring that, okay, if you have 2 completely separate files and it's like building out these 2 different SHAs, what are the odds that any two at random would come out with the exact same shot? Because it is possible. It's about the same as having a perfect March Madness bracket, which anyone that's into that's like, oh. That includes the play-in games that happen before it. And then after you've done that, you have your perfect bracket, you would have to die in a terrible skydiving accident that year. So that's about the odds of what it would take to have that duplication. So I think you're safe. So cat file -t, T will stand for type, and the type is a blob. Similarly, you can say S. You can see the size of the get object. And then finally is -p, where you can see the contents of the file. All right, so we still don't have the guides added yet. Let's go ahead and do that. Add guides. Okay, so all of our files are added, and we have two new objects created here. These two new objects, why don't we take a look at them quick? Get cat file -p. What was the one we had before? That was probably the 4E. Let's do 3AF9. Mona, yeah, that's one of our files. That's the content of one of our files. Let's do the same thing with the other one. Should be Lisa, right? Hey, there we go. So we've added 3 files, and there's a directory involved here. And if you know anything about get objects, you know, hey, there's supposed to be these things called trees that are get objects that should represent directories. Why isn't that in there yet? Well, right now, that's actually all getting managed by the index. So let's actually swap out this bottom command here. This is getting kind of crowded because we have these extra lines with the splitting out. So I have another command, which under the covers is an overloading of cat file and this really confusing looking thing. But it's kind of neat. It'll show us just our get objects and the type along with it. So now that we've added everything, now we want to commit. This is our first commit. So exciting. Jungle Tour, welcome. All right, what just happened? We still have the same 3 blobs, but now we have 2 trees, and we have a commit. Well, I'm excited about this commit thing. Let's get into that first. Get cat file. We can do that for commits even. 33C1. Okay, so inside of here we see we have a tree, which every commit is going to have a tree that refers to the root directory of what we had for our project. And then it's going to have your author, committer, with timestamps and all that good stuff. The first commit is the only one that doesn't have a parent attached to it. Now, the parent would be like a parent commit. So usually when you build a commit, it goes on top of another commit, whatever one you were working off of. And so the one that you're working off of becomes the parent of the next one that you just created. The first one doesn't have a parent. Kind of sad. But it has the support of all the other commits. So it's got that going for it. All right, so the first tree, 5DED, we can see it down in here. So we know that this one is going to be the root one for our project. Let's take a look at it. 5DED. Okay, cool. So the root, we can even take a peek at what we had here. So the root had a reference to one file, and it had a reference to one directory, or one tree in this case. So it has a blob and it has a tree. And if we look, oh, look, it's got the file name right here. That's where that went. And then if we look at the tree that was inside of it, get cat file 7b66. Oh, what did I do? Oh, I didn't do my -p contents. And then it's our 2 files that were inside of it. So everything that we've done so far with Git has been fairly simple, but I wanted to take this step back, okay? Didn't want to make people bored. I want to take this step back to kind of show the foundation of what's going on under the covers in Git. And we're going to build off of this foundation in the next few demos. Let's take a quick look at what actually is going on inside of the Git index, just a little hint. So we might have seen back in here, let's see, let's find.git. So we have all kinds of stuff in here now. Oh, look, we even have like a ref heads master. We'll come back to that. Let's look at the index first. So we saw that there's a .git, this index thing. the index that you deal with, the index tree, is basically just this one file. And oh, wow, okay. I'm a terrible actor. Okay, so this is kind of weird to deal with. And there aren't a lot of plumbing commands for really dealing with trying to get information out of the index, and it's probably rare that you really need a whole lot of information. But one thing that you can do is get ls files, I'll say like a -s here. So that'll give you the condition of the state of the index. Now, one thing that some people might have the impression of with an index, because of the way that get status works, it shows you the diffs from the get status. But the index is actually always going to match an entire snapshot state that is somewhere in between the current head commit that you're working at and the working directory. So it's not just this empty bowl waiting for you to toss a couple things into and pull them back out. No, it's like a complete snapshot of everything that's going on. The other thing we wanted to look at really quick, get ref heads master. It's just a SHA. What is this? Get cat file -t 33c1. And it's just a commit. So another thing that a lot of people have kind of the wrong idea of what a branch is in Git, think that it's some powerhouse thing that everything in Git is based around. It's not. It's just a pointer. It's this entire file. It just says, oh, master, I'm over here. And that's all it does. So here we've journeyed through the save trail, the things that I know that you've definitely done in Git before, no questions. And we've kind of built out something that kind of resembles this image that I stole that kind of shows, okay, we have Git objects that are commits, we have Git objects that are trees, which match directories on our working directory, and we have Git objects that are blobs that match files on our directory. We're getting this now. All right, quick demo 2 already. Let's duplicate some files. Let's clear these out a little bit. We still have Git status out here. Let's see, down here, I think, what do we have? Xtree was probably, or Xobj. Okay, so now what I want to do is we had this guides directory. I'm going to copy that directory and its contents to a different location. So we're still going to keep the old one. We're just going to add another one on here. So we're going to take our guides directory, and we're going to call the new one animals, because the things that are the guides are also animals. And we all know how efficient duplication is. Okay, so you might notice down here that nothing changed. No new blobs were created whatsoever. Well, we didn't add it yet. Well, let's do that then. Okay, well, it still didn't create any new blobs. Well, why is that? Well, it's the files that we copied over. They have the same contents. They could even have different names, different paths. It doesn't matter. They have the same contents. So they come down and get built down into the exact same SHA and would occupy the same space in the Git object. So this gives Git the opportunity to have a lot of different files or a lot of different places that need to point to a file and not have to actually copy the file every single time. So commit A and commit B are a full tree of everything that's going on in Git, but you might only really have one file that's different between the commits. It would be really inefficient if we had built out an entire replication across the file system to represent each of those 2 commits. That would be ridiculous. So if we've only changed one file, well, we have almost exactly everything the same, except, well, we changed one of the blobs. And, well, because we changed one of the blobs, the tree that points to it, well, it's going to have to get updated because it needs to point using a new SHA, and then the tree that points to that tree needs to update on up the line. Another thing, let's make a commit. Guides are animals. Okay, so in this case, we have a new tree and one new commit. Let's actually first look at the commit that we've got. Actually, let's show. So our most recent one has commit 736F, so I know that's the one that we're dealing with here. 736F. All right, so it's pointing to a new tree that got created. Let's cat file it. Okay. Notice something here? We have two different trees. Their SHAs are exactly the same because both of them have the exact same even file names that they're pointing to, and those files have the exact same contents. So the SHAs all the way down from this point, you can reuse those. So it's a pop quiz, something to think about. If I ran this same tour tomorrow, would my SHAs all be the same? Yes, almost. So there is a slight difference. The only thing that would be different is that our commit includes something that is unique every time you make a commit. Does anyone remember what that is? Timestamp, yes. So if I make the exact same commit time after time after time, it's going to actually have a different SHA every single time because the timestamp is going to be different. So let's talk a little bit about the concept of dangling objects. So we get lost in Git because we kind of think, oh, my stuff got deleted. But there's a lot of things of where you've added them into the Git objects, and they kind of just stay there. Let's check that out. Dangling objects. Git object reference. Oh, we should have a thing here. Okay, so every single Git object is typically going to have something that points to it, that keeps it into the realm of what Git says, these are reachable things in the realm. First, we have a blob. Well, what can reference a blob? Interaction time. A tree. And then that could be referenced by another tree. If that tree is the root tree, that could be referenced by a commit, which could be referenced by another commit, which probably could be referenced by a branch pointer. And if it's the branch that we're having checked out right now, it would have a pointer to it even called head. So we have like this chain of keeping things alive. If you're programmers that have to deal with a language that thinks about garbage collection, this might be familiar. So we have the concept of objects that you're programming to, you have a variable name for it, and then once that goes out of scope, it's available to be garbage collected. Git kind of has the same concept, except for it really takes its time to do the garbage collecting. And in fact, you can even configure how long to say, do not get rid of this under any circumstances for this much time. And when I say this, I mean anything. So when we feel like we've gotten lost in Git, there's a lot of points in time of where it's like, oh, we can actually get back to that old thing because it still exists. It's just harder to find, and you need to know the tricks on how to find it. So this is where I get really, really excited. This is like the Doctor Strange stuff of where it changes paradigms in your mind and weird stuff starts happening. That was for you other theater people. So let's walk this same reference model, but go in the opposite direction. This is exactly how git log works. It starts at your ref pointers. Your ref pointers are your head. It's your branch pointers. And it starts from those. It works its way down. It says, okay, these are pointed to these commits, which are pointed to these commits, these commits, these commits, all the way down until, well, we've hit the one that is your first commit of your project. They all converge down. Here's the part that's going to change your life. These other commits are still here. And when you make changes in Git, usually what's happened is maybe you created some new commits and your branch pointers moved over to them. Your old commits are still there. You can still get to them. You just need to know how. And when you're the person that's, I don't know what just happened, I detach head, I don't know what's going on, and someone comes over and is like, well, just run this magic command, look how smart I am. And they don't bother to teach you what's actually going on. This is what they're doing. They're figuring out, oh, well, this feature branch, you actually wanted it on this missing commit over here, and okay, let's just reset hard your feature branch over to this new location. And oh, everything works now, everything's wonderful. I want this to be you after today. The one that stops having the heart attacks. Demo number 4, recovering lost commits. We're doing great on time right now. Follow my script, otherwise I forget things. I'm getting old. Okay, so, it says wipe the repo. That sounds dangerous. All right, this is where my pair programmer needs to make sure I don't RF my entire everything. So if we want to get rid of git, really all it is we want to get rid of the .git directory that's in our project. Oh no, it's fatal. And then we want to get rid of these files too. So this is the really dangerous one. Okay. Force push. Yes. Okay. So now we're starting completely from scratch here. Git status is freaking out. All right. So down here, I want to xlog, which, hey, let's look at what that does. It's also a watch command that's going to constantly refresh this every single second. This is doing log with some coloring, one line, graph, decorate, a brief commit, all. So you probably have something like this aliased on your system, and if you don't, figure it out. Get it on your system so you don't have to try to type all this out. What is this thing? Because this is so useful. This is so useful. It might also just be useful to run a visual command if you don't already use one. The Rowan J getx is awesome. I love it. There's a lot of other tools that are really involved. GitHub's got a good one. GitKraken. There's GitTower. But hey, we're just doing command line today for the most part. So I have another script. Well, we need to git init first, right? All right, so now we have a git directory. Let's try xlog again. Let's try xstat again. So we don't have any commits. So there's nothing in our log as of yet. There's nothing on our git status. I have a command called rando commit, and I'm going to pass 3. So this is going to create a file called rando.txt, find a random line of text, shove it into there, add it, do a commit, and then it's going to go through that process 3 times. It's magically delicious for demos. I can all of a sudden, hey, I've got 3 commits, and it didn't take me 15 minutes to set it up. Okay, so from this point, let's see, okay. We have the commit that we're looking at right now. So we have head pointed to master, if you've never read this before, and master is pointed to this commit here. This is the one we're working off of. Let's copy that for right now. And actually, let's amend our commit. Now, if you've never done an amend before, it takes whatever current commit you're working on, and it kind of like unboxes it, and then lets you change it, and then package it back up. But I'm going to do something really weird. I'm not going to change anything. But our old SHA of 767 6CD, it's no longer reachable. It's a dangling commit. It is still there, though, I promise you. But now we see a different commit. And we can even diff on our system. Let's see, get cat file -p 33 cd, and then we can compare it to get cat file -p, this other thing. And here we can see the difference is, like we said before, it's just the timestamp. That's the only thing that's changed. So it didn't really change the existing commit when I amended it. It just created a new one, and it kind of just got set aside because there's nothing that references the old commit anymore. Both of these commits now exist, but we only see the one because it's only tracking backwards from the branch pointers and the head pointer. What else do we have? Ooh, here's one way that we can keep track of things. How many people have done reflog before? That's it? Oh my gosh, I'm so excited. So our refs are head, and then we have refs for each one of our branches. The branches themselves are refs. So every ref has its ref log. You will never forget that now. So what reflog does, it's like a tracking system, which is great for jungle survival. We're going to track all of the places that your ref was pointing at. And there's one for master and there's one for head. If you don't specify anything, it's going to fall back on using head. Most Git commands kind of do that. Let's look at the head one first. So it's got this weird notation here. But this tells us all the places that it's been, and it usually gives us a kind of helpful message about what actually happened. So here we see our old 767 and 33 CDE, and we can actually do a straight up git reset, and I want to update everything across my entire working directory and index, so I say -- hard, and I can use this type of notation, this head at, and then the numbering system is how many places back in history you want to go. Head at 1. So that'll actually change which one we're pointing to down here, right? And it should match the 767 when we're done. Here, ready? There we go. All right, here's another demo. Oops, I meant to commit that to a different branch. How many people have done that? I mean, come on, really. Okay, one of the ways that you can avoid that, it's almost always you committed it to master on accident. Figure out how to get your branch name in your prompt. I can't stress this enough. There's so many times that you're just not giving yourself enough feedback. You're not seeing the git status coming. You're not seeing what branch you're on. You're just making assumptions that you're on it. And you might be just typing away and not even realizing, oh, there's error messages while you're doing this. And so you're not even in the state that you thought you were in because you had one typo 3 commands back, and now what in the world went wrong? This will help out a lot. So anyway, let's go back to Xlog here. Let's make a new commit. Rando commit. Zing. And then we say, oh no, using language, I meant to put that on the language branch, feature branch. And so now I need to figure out how to do that. And the first thing that we do, we kind of act like squirrels crossing the road that start to panic. You could be 90% of the way through all the things that you want to do. It doesn't matter. You're scared. You want to go back the exact opposite direction you came in and get hit by a car. So the instinct is, oh, I want to undo that commit. So you start Stack Overflowing. How do I undo a commit? And then you get this thing of like, well, get reset soft or whatever. And okay, that's great. And it'll work for you. But I want you to start thinking about things differently. The commit is not what's wrong here. Your branch pointers are wrong. Let's keep the commit. Don't undo it. Let's just move our branches around. So what we wanted to exist here, at this point, we need this commit. And we need the, language? Git branch language. When you create a new branch, you can specify a SHA if you want, but whatever one you're pointing at is the one it will default to. Good, so now we have a language branch that points to the correct commit. Wonderful. But now the thing that's wrong is master is pointing at it too, and we don't want that. We wanted master to point at the commit before this. We can actually move that around. So we can reset it hard, and we can use one of many different notations. We can actually, we see that the SHA is 767, and we could do that. Or we can use some of the special notation. I want to teach you a little bit of this. So one thing that you can do is you can use these caret symbols, and each time you type one, it's like, go back one parent, go back one parent. So it's like 767, all right, not that one, AF5C, and you can go all the way up. Another thing you can do is you can give this tilde followed by a number. And so the number says how many steps back to go. And if you've got weird merge commits, there's like some weird nomenclature you can use for getting all kinds of craziness. If you ever get to that point, you're probably doing something weird, and you shouldn't be doing that thing. So anyway, I like this one. So I want to reset master to move it up. There we go. So I didn't have to unpackage or undo or redo any commits. I just had to move my branch pointers around. Now, if you don't necessarily have the confidence to say, yes, okay, this exactly, and go do this at home, at least know that this is something that can be done. And I guess keep your eyes open for like Star Trek related stuff. I'll try to get some of these notes posted out to people. So instead of just having to watch the video when I think they're going to post them out on YouTube or something. Yes. Afterwards? Like, I got to text my mom about this, because she has no clue what I do. And she'll be like, oh, these cute monkeys. That's what you do all day? I don't know why my mom talks like that. She's actually a very nice person. I love her. Hi, Mom. Okay. Here's another one that we're going to try. Actually, let's jump back to the slides for a minute. Let's talk about keeping tidy. Oh, this isn't the order I thought it would go. Okay, so one of the git config things, like a lot of talks will say, like, here's all the git config stuff that you need to include. This is the only one that I'm including. Remote.prune true. You should be able to say git branch -a and list out your local and your remote branches and have it not be like this overwhelming mess. It should be very informative. And to be able to do that, you need to be deleting branches as you go because Git will not do it for you. It'll just leave all of those out there. So if you do the remote prune, one thing that happens is if someone deletes a branch out on the remote, when you do your git fetch, which you should be git fetching all the time, it will go ahead and remove your branches that go out to the remote and clean that up for you. So yeah, branch A all the time. Another thing is, like, what do you name your feature branches? I've probably been doing a bad job on my branch creation here. One thing that I started doing a few months ago at a project was putting my initials as the very, very beginning. If you're on a smaller team especially, I think this is really, really nice because of this. If I come in and I say git branch -a and we're all being good citizens about our branches, I have just given myself a stand-up for everyone on my team. I see all the initials, and then I see what it is that they're working on lately. Now, MP might have 2 or 3 branches that are currently being worked on at the time. That's fine. But I should only ever see like a few of them listed out. And I feel like stand-up should be something of where you go into it and feel like, oh, great, this felt like a waste of time. No, that's a good thing. That is a very, very good sign that your team is healthy, is if you go in and there are no surprises in stand-up. Everything that gets said is stuff that you already know. This is one of those ways that you can get that kind of information. Okay, some of the last ones. Oops, I did not mean to delete that branch. We're going to talk about merchant rebase just a little bit if we have time. Okay, I don't even have a script for this one. We're doing this on the fly. Okay, so xlog. Let's check out language. So let's make head point to the language branch. So we're working off of that commit now. Let's add a few more commits just to make this branch look really valuable. And then we're going to change back out to master. And then let's say, okay, let's keep things tidy. I want to delete this language branch. Oh, wonderful. It's not fully merged. Use capital D. It's actually one of the nice things Git has ever done. So our branch is deleted, but really you know better. You know better now. You know that the pointer, the ref for that branch was what got deleted. Those commits are still out there somewhere. We could recreate our branch. Oh, it was so wonderful. It told us where the branch was pointing when we deleted it. But another thing that we could do is we could check the ref log. It was the language branch, right? Oh no, when we deleted the branch, it deleted that branch's ref log. Oh, that was kind of painful. Was this the one? I think it might be. Is it? Let's try it. Git branch. Let's name it. Was it language? Was that the one? Was that the right thing? There we go. We brought it back. So all you need to know is where it was pointing before you deleted it. And it tells you which place it was pointing at, but you also lost your ref log. So if you lose track of that SHA that it gives you when you delete it, you're kind of hosed. So if you're trying to tidy up for the first time and you're going to be a little bit nervous, that's probably perfectly fine. Xref? Oh, that wasn't what I wanted. So sometimes you could end up putting binary garbage and totally mess up your terminal. Luckily, I have an alias called xwhat that cleans it up. So yeah, here's some of my stuff here. Xref. I thought I had. Okay. All right. So anyway, there's a command that I thought I had off the top, but basically you could, let's just do ref parse. Maybe right before you delete it, maybe you want to try to save off your name of like language. So ref parse will tell you what SHA is pointing at that point in time, and then I am scared. So that you could shovel those into a file before you delete stuff if you're just, that worried that maybe I'm going to need this branch later. Well, you can probably get to it later. Git will probably keep those commits around. Oh, now we have this in our history. All right, so now we're down to about 10 minutes. How are we feeling so far? This is like our brains exploding, or are we happy? Are we happy people that we don't have to hate our jobs on Monday again? I wanted to talk just a little bit about merge and rebase. You're probably already familiar with at least merge for sure, and rebase might scare you a little bit. You just know that, okay, it changes history. Another thing to be aware of, if you're changing history, which basically means I've taken my branch pointer and I've moved it to a different commit that isn't a commit that goes up the chain. If I move it to a different place, like a completely different commit, I've changed the history. So now when I push, I have to force with lease. Don't do this, but do it if you have to, but don't. Yeah, force push with lease, and now it's going to mess up anyone else that needs to work with that branch. Now, if you're just working on your own little private feature branch and you've pushed it out, no one's really looking at it yet, it's probably safe. Go ahead and force with lease if you need to. But if it's master, don't be changing history, okay? Do these kinds of changing history things with your own little branches and push those out if you need to. And if you ever do, if you're worried that someone might have grabbed your branch and then they're working off of it, just talk to them. Just make sure, hey, I want to do this force push. Is that cool? No? Okay, well, maybe we'll revert the commit instead. So merging, when you need to do a merge, there's a couple different things that can happen. So let's actually get rid of our language branch again, just to clean things up. So now we're on master. There's 3 commits good behind us. Let's make a couple more. Rando commit 2. Okay, well, I actually wanted there to be a branch called good, and let's put it on the are we still good? 7676. Okay, so that's down there. Now I want my head to point at good, so that when I add new commits, it's going to also move the branch pointer up with it and add the commits there. So let's check out good. Okay, now let's rando commit again. Do 2 there. So we've had 2 things kind of split out. Now this is actually like a normal merge. So actually, let's undo this. Let's do it this way. Okay, so a normal merge is usually you're merging into master. So let's check out master. And we want to say get merge good. Automatic merge failed, which is what I actually expected. So in this case, I need to fix some things on rando. So we have, I want to keep all of it. And then now I need to add it. And let's commit and keep merge branch good. So let's look at the contents of B8, B7. All right, so in this case, we've put all the content together, and this time we can say, we have more than one parent coming off of this commit. And then when you one-line graph it in your Git log, it shows it split out. Most of the time, a merge is probably going to look like this. But one thing that's kind of confusing is that there's actually a few other things that could happen instead. So let's get branch-d, get rid of good. And actually, let's roll back this commit. Git reset hard. And let's go back. Let's use tilde1 this time. Okay, so it was like that branch almost never existed. Let's say we actually wanted branch hurt. And let's rando commit it a couple times. All right. Oh no, we moved master up. Well, that's fine. Okay, so let's say, what if we tried to merge hurt into master? Well, you might say, if you've been paying attention, or even if you haven't, I don't know, that doesn't really make sense because master already has everything that hurt has to offer. Is like master is completely out of hurt's league right now. If you were to go the other direction, let's check out hurt, and let's try to merge master into it. Now here's another special condition of where that weird merge commit that creates two parents doesn't happen. Because what happens is called a fast forward merge. So the only thing that really needs to happen there is we don't need to create any new commits. We just need to move the pointer for hurt to the same place that master is. Oh, merg. I should alias merg to be merge. Okay. So, and I can even undo that. Reset, hard. I don't know. Let's say it was 988. So I can actually mimic doing a fast forward merge by just saying get reset hard. And I want to say the place that I want to reset my head and the hurt branch to is actually the location of master. So that would do the same thing as what a fast forward merge would do. There's also, we have enough time to do this. Let's go down, check out 9884. Check this out. We haven't seen this yet. Detached head is perfectly safe. You don't even need branches. The only difference is that Git's going to forget about a lot of the things if you don't have refs keeping track of what is reachable. So in this case, I want more random commits. Let's do 2 more. And let's actually check out a new branch at our location and call it tourist. Okay, so git check out hurt. Let's say I want to merge hurt into tourist, and I want to make it not do that weird branchy thing from the merge. So what I can do in that case is I need to be on git check out tourist, and this is the last thing. Git merge, we can squash, make sure I'm doing this right, hurt. Merge conflict, that's to be expected. Rando, let's fix our merge conflict like a cowboy. Yeah! Git, add the file. Git commit. All right, keep the same message. So it took everything that it would have put up into that merge, but it doesn't really respect hurt as if it was one of the parents. So when you're merging things into master for your main line, this is actually a pretty good idea, and there's an option if you're using a flow using GitHub to do this with your pull requests to squash everything. It's a lot easier to revert a single feature this way, and it makes everything cleaner and a lot easier to read. We didn't get to talk about rebase. Sorry, ran out of time. But thank you so much for coming. If you had any questions, and I'll try to post some notes out to it later. I know our internet's not super great, but that's the room that you can go out to on Slack if you're on the Star Trek Slack, 2018 Thanos, and I'll be out there at some point today answering questions or whatever.
Say you don't know me, I recognize my face. Say you don't care who goes to that kind of place. Need